Hello YouTube, welcome back to my channel. So in today's tutorial we are going to learn about computer vision using Python. So we're going to be using Python to learn a lot of computer vision techniques. So this is going to be a new series on my channel. Okay, so the first thing we're going to learn in this video is how to install Opencv. You're going to be using Python Opencv and other modules, but for now, for the beginning, we'll just be using Python Opencv library. So the first thing you need to do is actually to install this library and to set up the Opencv so we can our programming environment. We set our programming environment up so we can begin coding. So the first thing I'm going to do, I'm going to create a directory, and with this directory we are going to just I'm going to call it computer let me just get the spelling right. So computer vision, just like that, underscore YouTube. Okay, so I'm going to change my directory into my computer vision directory, and if I do an ls Windows dir, you can see there's nothing inside of that directory. So now that we have that directory, I'm going to create a Python virtual environment, and to create a Python virtual environment, this is how you create a Python virtual environment. So you have to say Python 3 and then -m vnv and then vnv. Okay, so if you're on Windows, the command to create a virtual environment is different from if you're on Linux or Mac. So if you're on MacBook, this command should work for you, but if you're on Windows, you can just go how to create a virtual environment on Windows, and you get that instruction. So once that we have that, I'm going to activate. So I do an ls. You can see I have a folder here called vnv, and that's the name of my virtual environment folder. So I'm going to go ahead and actually activate it. So I'm going to do source vnv /bin /activate, and this is going to activate my virtual environment. And you can know the virtual environment is activated whenever you can see the name of the virtual environment within parentheses in front of the line within the terminal. So I'm just going to clear the terminal, and then I'm going to go ahead. Actually, I'm going to install Opencv. So I'm going to copy this, and I'm going to go back in my terminal and simply paste it in here. So I'm just going to paste it in here and install Opencv. So this is going to install Opencv on my machine. Once Opencv is installed, you can go ahead and actually write a very simple script to detect faces within an image. So whenever I give the program a static image, then the program will be able to tell the presence of a person's face within that image, so I have to draw a bounding box around that face. So that's what we're going to create. So now that you have Opencv installed, I'm going to clear the terminal, and I'm going to go ahead and actually create a requirement.txt file. So we're going to be using this as we go along the whole series, so it's just good to have a requirement.txt file. So I'm going to do pip freeze, and then just say requirements.txt. So this is going to create a requirement.txt, and it's going to move all our Python requirements into that file. Okay, so now that once that we have that, I'm going to go ahead and actually create another directory. So I'm going to call it face detection. So in face detection, just we're going to keep our face detection program. So once you have done that, what you can simply do is go ahead and actually I'm going to create now that you have that, what you can simply do is just create a program file. But before this, I'm going to open up my Visual Studio Code, or feel free to use any editor that you're comfortable using. Just open up your editor, and then we can begin coding. Okay, so now that I have Visual Studio Code open up, I'm just going to go ahead and close this. So in here, inside of my face detection folder, I'm going to create a file called static let's say static underscore let me just call it static.py. We are going to detect static image. You can just say static images.py. Okay, so I'm going to create that folder, and inside of that that file rather, so the file is inside of our folder called face detection. So I'm going to open up that, and in here what I'm simply going to do, I'm going to import cv2. So I'm going to import cv2 just like that. So once I have cv2 imported, the first thing one thing I need to do before I can begin to actually run this program is actually we need a cascade, a HA cascade for frontal face detection file. Okay, so I'm just going to go into my my GitHub page. So I have my GitHub page open up. So let me just open up my GitHub page, and now you can get this file from there. So I'm going to this repository is actually public, so you guys can go there and find that repository, and you can get the HA cascade frontal face underscore default.xml file. So I'm just going to go in here, and then in there I'm just going to find my my computer vision file. So I just committed this few minutes ago, so I'm going to open this up, and then I'm going to go into my face detection in here, and then I'm going to simply open up this. So once I have this open, now what I can simply do is just copy the content of there, and then go and save it inside of my project directory. So let's create a file called HA cascade underscore frontal face detection. just like this. So let me just actually, you can actually get the name, copy this name from here. I'm just gonna copy it, and I'm going to go into my my VS Code, and inside VS Code I'm going to create a new file inside of face detection. So I'm going to paste that file in there and press enter. So it's going to create first this file in here. So now the content of this file is this right here. So let me just say raw, so I can copy all of that at once. Okay, so I'm just going to say raw, and then I'm going to do control A to select everything, and then control C to copy, and then I'll go back into my Visual Studio Code and do control V to paste all that content. So once that we have that done, great, we have our cascade file ready. So the first thing I'm going to do, I'm going to go ahead and actually I'm going to say load. The first thing we're going to load the cascade file. Okay, so in here what we're going to do, we're going to say face underscore cascade, and this is going to be cv2. So cv2 dot cascade. So we're going to say cascade classifier. So we're going to say cascade classifier, just like that, not the underscore convert, just the cascade classifier. And in here you need to provide the cascade file that we want, and this is going to be what we just have here, this file name here. So I think I can just go ahead and actually, let me just copy this file name because it's a bit long to type out. So I'm going to rename, select all, and I'm going to copy that, and then I'm going to simply paste it in here. Great. So now that we have that cascade file loaded, I'm also going to load the image that you're going to be trying to detect a face in. So it's going to be cv2 dot it's going to be imread. And then you need to provide in the name of that file that you want to read. So you can go ahead on the internet and find any picture having a face in it, and then you can use it yet and try to detect that face. In this case, I have a picture here. I downloaded this picture from Pixel. So I'm just going to copy this picture. I'm going to copy it, and I'm going to go into my desktop, and I'm going to go into computer vision, and I'm going to go into face detection, and then simply paste it in there. So now once we have that, we're having an error. So it says that let me just say try again. We're having that error. So let me just go and copy that image, or let's actually go to Pixel and try to download a new image rather. Or you can just, I think I have the image already downloaded, so there's no point of doing that. I'm just going to go into my downloads and simply get that image, and the image is available on my GitHub page, so you can find that image right there. So I'm going to go in here and simply go into face detection and paste that in there. I hope this time it pastes. Yeah, so I'm going to rename it, and I'm going to call it test. Let me just rename it. So I'm going to rename it. So I'm just going to rename it and then call it test underscore 01. Okay, .jpg. So once I have that image already loaded, and the image can be found here, so I'm going to specify the name of that image right here. So I'm going to say test underscore 01.jpg, just like that. So this is going to load our image for us. Let me just keep a comment here. It's going to be load image file, just like that. So we're going to load the image file. So once the image is already loaded, you're going to convert this image into a grayscale image. So I'm just going to put it comment here and just say convert to grayscale, just like that. So once we have that, you're going to say gray, let's call it gray, or call it gray image if you want. So we're going to do cv2 dot, you're going to now convert this. You're going to say cvt color, this one, and then you're going to say image. You're going to put in the image here, the name of that image, which we call it as img, which we store it in this variable. That's the name of the variable we're going to provide in here. And then you're going to do cv2 dot color. I'm going to convert this into a grayscale image. So we're going to say color underscore bg. I think I can find it here. So it's color, this one right here. Yeah, so we're going to convert this into a grayscale image. This is going to help us convert our image into a grayscale image. So you can even open up this image and see what's the content of this image. So now that you've converted the image into a grayscale, what's left now is to detect what the face within an image. So we're going to just simply go ahead and actually detect the presence of a face within an image. So we're going to say detect faces. So this could be one face or it could be multiple faces. So we're going to say faces, and this is going to be face underscore cascade, which is this cascade we just loaded in. We're going to now detect the face based on this cascade. So we're going to say detect you're going to detect multi-scale just like this, and then you're going to pass in the image that you want to take. So we're going to pass in the grayscale image, then you're going to provide in a couple more of parameters. So the first thing we can provide is in here we can provide in a couple of other parameters. So I'm just going to go ahead and actually specify those parameters in there. So I'm going to go ahead and specify 1.1. That is the scaling that you're going to pass in. You're going to pass in this scaling because the images can be from the images in the faces within the image can be of different scales. So we're going to scale them to 1.1, and then I'm going to pass in 4 as the, I forgot the name of this parameter, this argument. If I remember it, I will just tell it in a second. So once we have that done, we can go ahead and actually draw. Okay, this is going to detect all the faces, and all the faces are going to be stored in here. So we're going to go ahead and actually draw a rectangle around each face. So we're going to say for x, y, w, h, which is the x, y, w. So we're going to loop through this, and we're going to say for x, y, w, h in faces. So we're going to get all the coordinates from the faces. What you're going to do, we're going to use those coordinates to draw a box around the face. So we're going to say cv2.rectangle, and then in here we're going to provide in the rectangle. So we're going to pass in the image that we just we loaded originally. We're going to pass in x and y, and then you're going to pass in x plus y, x plus w, and then y plus the height. Okay, so this is actually a plus or plus height, just like this. And then you're also going to provide in the color of the box that you want. So you can this is going to be the RGB values. Okay, so I'm going to use 255, 255, and then I can say 0, and then the thickness of that bounding box, I'm going to say it's going to be 2. Okay, so now that we have that, you can just go ahead and actually display the image. So this is going to be, let me just keep a comment here. So it's going to be draw rectangle around so there can be draw rectangle around faces, just like that. And then in here now we're going to go ahead and actually display the output. So output, let's say output display, just like that. And what you're going to do is cv2 dot actually cv2 dot ImShow, and you're going to pass in, you're going to say image, and then you're going to pass in here image, just like that. And you're going to do cv2, you're going to wait for this cv2 so that the window doesn't close. So you're going to say you're going to wait for the key to be pressed for the window to be closed. So we're going to now wait for the key to be pressed, and this is going to be the escape key. It means that if you press the escape key, the window should close. So now if you run the program, let me just go back to the terminal, and then let's run this program. So I'm going to do I'm going to change directory into my faces, and then I make sure I have it here. I'm going to do Python 3 static, and then I'm going to run that. So this is going to open up a window, and you can see the window here within the image inside, and you can see it drew that bounding box around that image. So that's how you can simply write a Python program. So now if you press escape, that's going to close, and it's going to exit the program. So if you know, that's how it's easy really to write a Python program to detect a face within an image. So you can provide in multiple faces. This will detect all the faces and store them in here, and then loop through each of those faces and draw a bounding box around them. So if you have an image having 2 faces, then it will loop through and draw a bounding box around each of those faces. So that's basically it for this. So now that you have seen the basic way of drawing this bounding box around the face, let's look at some of the argument that you have provided in here. So we can provide in the grayscale image, and you can provide in the scale factor. So this is called the scale factor, and then this is the scale factor, which is just 1.1 scale factor. And then you can also provide in the mean number of neighbors. So mean neighbors, mean numbers. So we can say that to be I can say it's 4. This is just make our mode. It affects the accuracy of the bounding boxes being drawn, since not every object or not every part of the image is on face, but only some specific parts of that image actually is a face. So the mean number of neighbors defines how many objects are detected near the current one before it declares the face found. So it defines how many objects are detected around the current face before it declares that actual face to be a face, and then the bounding blocks get drawn around this. So we can also specify the mean size. So you can go ahead here and specify the mean size. So you can specify the mean size, and then inside you can specify 30 by 30 if you want. So you can say 30, 30. So let me just make sure I remove that. So yeah, that's basically it, and then need to draw a bounding box around that. So now that you have done that, you can go ahead and actually run the program again and see how it performs. So you can change these parameters, tune them a bit, and see how your model performs. And you can see it's detecting the image, and there's no problem for now. So you can actually load in an image containing multiple faces, and the program will go ahead and detect all the faces within the image. So that's how basically it is. So thanks for watching, guys. See you in the next one. So in the next video, in the next tutorial, we'll actually create a video, detect images within a video. Okay, so thanks for watching. If you are new to the channel, kindly consider subscribing and hit the notification bell so you can stay updated whenever I upload future videos. Thanks for watching. See you in the next one. Keep safe.